Alright guys, here's your outline, your review, but more importantly, your practice is really with the extra credit, which is referred to on the end of this review. Excuse me. If you need references, I'm going to go over some of the pages we did in the unit to help you study. So the first part, we did this in class, knowing your parts. Excuse me, sorry. Knowing your parts to your parabola. These are the key features you have to read off of a graph. We were able to get this off of sorry, let me go up. This pink graphic organizer. Remember, on this video or any video, you can always pause it and rewind anytime you need to. But down here, the key components, they were already labeled for us. Okay. Also, we add the notes of some additional words that we use for those components, like your root is known as your x-intercept. We also refer it as the zero or the solution. Okay. So if you needed this, because if you were absent, we can go over it again. Your axis of symmetry, this is the line of symmetry that cuts the parabola in half. Oops, sorry. I feel like I hit something. I need to take that off. There it is right there. Remember, your axis of symmetry goes through the vertex. That is this point, the turning point of that parabola, the highest or lowest. This is a minimum. Zero is the same thing as your x-intercepts. So right here where the parabola touches the x-axis, that's our solution, our zeros. We can write it as an ordered pair or in the bracket to show both x values. And then our y-intercept, we're already familiar with that. That's where it touches the y-axis right here. Your domain is always all real numbers. And your range corresponds with your max or min. Since this parabola is opening up, it's going to be greater than -1. Okay. So then we're going to do the same thing, ask for the same information, just giving you the equation. Excuse me. So you could use your graphing calculator to do that. You need to go to y equals, put a negative parentheses, x, I think it was +3. Let me double check. +3 and +5. Okay, so we go, we have x +3, close the parentheses and square it, and then we're going to have +5. And we want to graph to see what the parabola is doing. We want to see the vertex. We see that since it's opening down, it has a minimum. Now the graphing calculator could help you see that if you don't see it in the table. So if your table, you have to hit second graph, remember, and we're looking for where the pattern, the symmetry pattern, where the numbers kind of get repeated, and then I can start seeing it right here. So the 4 is repeated, the 1 is repeated. So there's my vertex, okay? But like I was going to say, if you forgot, you could always do second trace, and this has a max, which is number 4. And this is when we move, this is left bound, we have to move the cursor to the left of the parabola, and then move the cursor to the right, and hit enter, and then enter again, and there's our max. It's at -3, -5. So you can use your table, second graph, to help you graph the points on your on this grid here. So we're gonna start off with our vertex, -3, 5, put a point there. Then I believe we had a point at -2, 4, and at 4, -4, 4. And then it was here. And then the y-intercept is, I believe, I think it's at 4. Let me double check. Yeah, -4. Okay. So right here, and then we're just kind of sketching a graph through these points, showing the path of the parabola. So it's going to go up here, sorry, and then it's going to curve, turn, and come down. So the parts, if this opens down, we saw the vertex was -3, 5. Now also, because this is in vertex form, remember it's a parentheses x minus h squared plus k. Your vertex is always the h comma k. And we basically do the opposite sign right here, the opposite sign. I don't know if you need the pen right there. When we take it out of parentheses. So that's why this was a -3. Your axis of symmetry goes through this vertex point. It's the vertex line. So this is x equals -3. This had a max. The max value meaning how high is it? To get that value, you have to look at the y value here. The max is at a 5. Our y-intercept, this is where it touches the y-axis, was down here, is at 0, comma, -4. Our domain is always our real numbers, and our range corresponds with our max. So this is opening down, excuse me, this y is less than or equal to 5. Now I want to talk about the roots. Remember, the roots are where it touches the axis, is your x-intercept. And if you look, even on my sketch, these are not exact points. I can go back to this calculator and go to my graph, and I can see, yeah, it's not hitting exactly on that tick mark. So just kind of want to recap how to get to that, because sometimes your answer could be a decimal. To make the calculator give you that value, you have to go back to y equals and put 0 for y2. Hit graph, because we're going to look for the intersection of those two lines, the red line and the blue line. So now we're going to hit second trace, pick intersection was 5, and then hit enter 3 times. 1, 2, 3. And there's it is right here. It's at a negative 0.763923. So you can put a negative 0.76 for that one. But because I see there's 2 intercepts, I have to repeat those steps. Hit second trace, hit 5. But now I need to tell the calculator I'm move to the left, put the blinking cursor on the left side, hit enter 3 times, and then my negative 0.5236. So negative 5.24 and a negative 0.76. So we're just going to record those here. You can have decimal answers. 5.24 and negative 0.76. I'm just rounding to the nearest hundreds. Just match your decimal to your answer choice. Okay. Now, we have another example here. And I'm just going to get to my answers using the vertex form. Just kind of remember, we have a parentheses x minus h, close the parentheses squared plus k. So a couple things. I know this is going to open down because there's a negative sign right here. Right there. Because I see this negative is going to open down. And then I'm just going to pull out the vertex. Do the opposite of the h. So that means a -2. Keep the k, that's 1. So I can go straight, put that there. I can see my axis of symmetry is going to go through that point. So this would be x equals -2. And because I know it's going to be opening down, it's going to be a max. And I just have to find where that max is. It's going to be where that vertex is. So it's at 1. But if you don't see it out of pulling out, you can just go back to your calculator. Let's go to y equals, we're going to clear this one out. I'm going to do a negative and then 1/4. So we're going to do alpha x, put a 1 on top, down, put a 4. And then we're going to put our parentheses, x plus 2, close the parentheses and square it, and then plus 1. And one of the things I'm hoping you can see or remember, that if my a is a fraction here, I'm going to graph it, it's going to make it wider, okay? And then this one I can see, these are going to be exact, I believe. I can do my second trace, hit my 5, do my intersect. I'm going to come to this one just because the other one I see is at the origin. I enter 3 times. Yep, it is at a -4, 0. So I can see the shape of my graph. And so if I go back to my, here is one of the zeros right here, a -4, and then here. Let's turn this off. And so it's going out this way, and then coming, and then, sorry about the sketch. It's coming this way, like such. So our y-intercept is at 0, 0. Domain is all real numbers. Range is less than or equal to 1. And then for our roots, it's where it touches the x-axis. Remember, these are your zeros or your roots. Okay, they mean the same thing. So I can do either the little bracket of -4, comma 0, or I can write it as an ordered pair. All right, so now that we have that, we're going to ask you to find these parts using some real world graph examples or just reading a diagram. And I just kind of want to recap some stuff. Remember, your domain is your x values, and your y and your range is your y values. And we're getting this from the order pairs. Okay, order pair is always an x, comma y. And if I look at, they want you to use the graph above that shows the height of the path of a golf ball. As a quadratic fraction, because equation is the shape of a parabola. What is the domain? So domain, remember, is the x value. So I have to look. There's my x is 0. Then it goes to 110, and then it comes all the way out to 230. So my domain is the inequality going from the lowest number, which is 0, is less than or equal to x, which is less than or equal to the 230. Your range is your y values. So the smallest it gets on y is actually this 0 here. The highest, the max value, is when you look from bottom to top, is the 36. So this is 0 is less than or equal to 36. I mean, y, which is less than or equal to 36. Okay. Now, if you don't have a picture to read the information off the graph, then you're going to have to use the equation. On this one, they just want the vertex. So here we're just going to type in our equation. Now, I think this had a typo, so I'm going to do both versions because I believe this should have been the middle term, because this is supposed to be in standard form, ax squared plus bx plus c. So I'm going to do both equations in case if you read this as 4x squared plus 12 plus 8. Well, then we should be combining these like terms right here. So this actually is 4x squared plus 20. Okay, so I'm going to just show both in case you read it as a 12x versus a 12. Okay, so on the first equation, I'm going to clear this out. We have 4x squared plus the 12x plus 8. And we're going to graph that. And we're going to look for this vertex. And I can use the calculator to do that, which is second trace. And it has a minimum. And I need to move my cursor to the left, enter, to the right, enter. And then I can see that is at, this is actually going to be negative 1.5 and 1. Now, also, let me go back to this form. Negative 1.5. Negative 1, I believe that was right. Yeah. If I thought it read it as 4x squared plus 12 plus 8, I'm going to delete this. I'm going to change this to 20 and graph it. Okay. Now here's where I don't see the graph. To help your window, guys, go back to your table. And if I look at my values here, look where it starts to kind of like repeat. And so I can start to see, I'm looking at this lowest value of like 20 right here, and then it starts repeating 24 and my 36. So right now my window is showing a max of 10. So right now it's already just too small. So what I'm going to do is I'm going to change this value. Let's just change it to 50 for right now. Okay, and just see what happens. Now I can start to see it. Okay, so on this, if I read the graph, so I'm going to put both equations up here. So if I read it as this version, then the it's 0, 20 to be the vertex. Now I'm just going to get this next one, number 11, using vertex form. Just understanding that your vertex is the h comma k. And so I'm doing the opposite. So this would be -5 comma -3. Okay. Now if we go to our next concept or section, is making sure you can determine the values that are true off the parabola. So on here we have, this is the solution is x equals -3. Now if it's a solution, that means it is an x-intercept. So I just got to check that. And yep, it does touch the x-axis at a -3. The y-intercept is 0, 9, so I go up and right there, yep, that is 0, 9. So that is true. And then it says axis, that should be axis of symmetry. X equals -3. Well, yep, the axis. So it is all three. Okay. It is all of these are true statements. All right, so now we're getting into vertex form and transformations. This is when we're going to look at our tan color notes. I'll show those here in a second. I also want to remind you that you can use your Desmos calculator. I'll go back, go to Desmos.com, up here with math tools. Take your Desmos calculator right there. And then you can type that in. So on this first one, I'm going to type it like it's written in on the problem. It says you're going to do an f of x. Look at this keyboard right. Oops, maybe it's not going to let me do. Okay, hold on just a second. I gotta fix this. Okay, so I have to put the cursor in here and type f of x. This is going to be our parent. So I'm going to do parentheses, parentheses x. And it's going to equal my x squared. To get the x squared, you can use the option down here to get to the keypad of an x squared. Or you could just do the shift 6, and then there's our x squared. And we want to look at the transformation. So on the problem, that's why I'm going to go to this next row. If I look here. So we're going to create the function g sub x, which is equal to f parentheses x minus 2. So if we go back to our Desmos calculator, we'll do g sub x and then equal f parentheses x minus 2 parentheses, and I think I forgot what I'm missing the other part, plus 5. Okay, so I need plus 5, and right now I don't really see the graph, but what I might need to do is zoom in and zoom out. Oh, I forgot to put equals. My bad. Equals. Yeah, there. Now it's popping up. And now the reason why I want to reference your Desmos calculator, because sometimes if you forget to do the y equals, and then now we're doing f of, you would have to understand that to write it differently on the TI. And then too, you can kind of click on the graphs to get points. Okay. It's another way of using it. They want to describe how it changed. Well, this is in vertex form. What's in the parentheses is your horizontal. I can see this is the parent and move to the right 2, and then it went up 5. I can physically see that. So it translated 2 units to the right and 5 units up. Okay. So then we're going to be giving you some descriptions, which comparing your parent function. And so this one is a y equals, and you can put this in the calculator as well to help you see how it changed. Now, what I was referring to, let me show you what notes you need to look at. All right, this is the graphing quadratic and vertex form. These are the notes that we did, or you did with the Edpuzzle, but then we did the second half together. So you talk about the reflection, talk about the transformation analysis. So I would use that to kind of refresh in your memory. But a couple things, I can also use your calculator, but I see the negative sign, so that means it's going to reflect, meaning it's going to open down. Okay. And then here's my h, because this is x minus h, parentheses squared, that's h, sorry, plus k. So my h tells me how much is shifting left and right. And remember, we do the opposite. I know that's a negative one, and we think normally on the number line, okay, this is your x, this is your y. We think normally the number line is negative numbers, but we're going to do the opposite. So this is meaning it's translating to the right one, and then down 5. Opens down, reflected. So this was D. Okay. Maybe pause the video and try to see if you can get number 15. You want to check your understanding on this. Okay. Again, we're doing which is true. So here, again, I see a negative sign, so that means it's opening down. Okay. Which, when anything opens down, it's going to have a max value. To open up would give you a minimum. Okay. So we don't have this. That's positive. This is negative. So we have a vertex. This vertex, because there's no h, that would be 0, but this would be your k. It would be at positive 5. So the graph has a max value at 0, comma 5. Okay, it's not wider. It would have to be a fraction here to be wider. It's going to be narrower. All right, so then we're going into transforming into standard form. This was the yellow notes. Let me show you that real quick. All right, so this is the yellow notes I was referring to, and then we had our steps right here that we need to follow. So I'm just going to kind of put the acronym of those steps. We start with the E, which is expand, then the FOIL, distribute, and then combine like terms. So if I expand, we're expanding the parentheses, meaning the exponent shows we have 2 factors of that. So we should have 2 parentheses x minus 4 and x minus 4 twice, and then minus 2. Then we're doing the FOIL method, the first, outer, inner, last. Keep the 2 outside the parentheses. This would be x squared minus 4x, this is the outer, minus 4x again, that's the inner, plus 16. Close the parentheses, and then we have minus 2. Then what we need to do is distribute, that was the D. So it would be 2x squared minus 8x minus 8x plus 32, and then minus 2. Then combine our like terms here. We have our x's we can combine here. So 2x squared minus 16x. And then our numbers, we have a positive 32 minus 2 gives us plus 30. So just like when we looked at some sample star questions on our notes, you're going to have some that require you to just write out the equation and then match it with your answer choices. So if we struggle or we need to check our work, remember, you can always put your given equation in the calculator. This is our original equation. I can put this in as y1, and then I could put an answer choice, I can do one at a time, as y2. So, and then check your graph. So I'm just going to model that with you. If I go to y equals here, we're going to do 3 parentheses. Oh, sorry, I forgot that we have minus 5 and 25. So that's 1 parentheses squared. Oops, I forgot my x. Go back. X minus 1 parentheses squared. And then minus, oops, delete that. Minus 25. And then now in y2, I'm putting in the answer choice to check. We had the standard form here, 3x squared minus 3x minus 11. Okay. And what you could do is check your graph to see if they're the same. I can see right there they don't match. I'm gonna do zoom standard, just See, they don't match. And then, or you could just take your table. If you do second graph, if this was an answer, the values in the table will be the exact same. So this doesn't work. Or we can just follow our steps, which is the F, B, C, and work that out as there. So I'm gonna just use the calculator check. I'm gonna check answer choice B because I think this is it. Just kind of looking at this, gonna be +3 and then 3. Yeah, let's try it because 3x squared minus 6x minus 22. So I'm gonna change my y to 6x minus 2. And then I'm gonna look at the table. And yeah, look, if I look at my table right here, the numbers are all the same. So that means it is equivalent, it is a match, it works. So this one was B. Okay. And then our last section is our green notes that we had, which is difference of squares. And then we had also the white paper with factoring trinomial. So the sample problems, if I'm going to take the square root, you have to have the x squared isolate, which it is equal to the 49. Take the square root. This is going to be x equals, so we're going to be a positive -7. Now, in a problem like this, taking the square root, I can't because this x term is not isolated. So I first have to add the 32 on both sides. 2x squared equals 32. But then I still have to isolate the x squared, so I have to divide by 32. So now I have x squared equals 16. And then I'm taking the square root. So x here is a plus or minus 4. Okay. Now, here is when we're doing factoring. This is in standard form. Your ax squared plus bx plus c. And this is where the a is an invisible 1. So this is when we go to our x puzzle. Remember the last term, the c goes on the top, the b goes on the bottom. Our c here is 20. Our b is a -9. So we're looking for factors of 20. But the sum of -9, well, that would be -5 and -4. So the factor form would be x minus 5 and x minus 4. But remember when we saw we do the opposite and we do +5 and +4, and that was right here with B. So after you're done with this, please go to quizzes. Let me show you that quizzes to practice. I want to show you some of the tools that are on there. To really get a gauge, you want to try to do the quiz without looking at your review or your notes. You get multiple attempts, but if you're having to redo a problem, that's an indicator you might need to study that type of problem or that skill. Hold on, let me go to the quizzes. All right, so when you get into quizzes, go to your dashboard, and then here are some of the practice things that there's your extra credit. So you just click on that, load your game, and start. One of the tools that you now have access to, it is starting with the goal of 80%. Remember 85 though, okay? Is here we're just describing, and I don't think it's showing, so let me go fix something real quick. Hold on. You should have a tool down here for your calculator. Hold on. Okay, this is where I was getting at because we're gonna go to next. Really hit the tools. It goes through the demo for you. You can access a calculator. So like for a problem like this, I can go ahead and hit my graphing calculator and it'll open up the screen. I think we can even move it so we can kind of, let's see if it'll let me. Nope. Oh, right here. Oh, okay. So what we're doing is make sure -2, so I could type in y equals -2 parentheses. We have x plus 3 and then plus 1. So x plus 3 close. cursor would be beneficial plus 3. Close parentheses. We're going to square that. And then we have plus 1. Okay, so we can look at the graph and kind of help us see which graphs match. I can kind of also click and see where these y-intercepts are at, like that. So I can minimize this because we're trying to find the graph, identify the function that transforms the parent. So if I needed to see the parent, I'll go back here. Let me go back to it. The parent is the y equals x squared. Okay, so obviously the parent is opening up. This one is opening down, and it shifts to the left here. So hopefully we're picking there. Okay. I just wanted to let you know you should have these tools here. And I think you have these options to use to help, depending on how many coins you have. So to solve a quadratic, this is use a quadratic formula, or you can use your graphic calculator. We talked about the formula yesterday. So just get this done and you be ready for your test tomorrow. Thank you.